Chris here has got quite a resume. Let's see, he is an aquatic ecologist with expertise. We're skipping everything else. We're going straight to the speaker.
Yeah, I'm not sure.
Micah's bullshit didn't work, which is a shame because I'm pretty confident I submitted two of the grumpiest fish.
I will fix it and get it on next month. I'm
All
sorry.
right, he's got like a 7-year-old slender buffalo head. He's real grumpy looking.
Just not working at all.
I worked really hard to get a photo too.
I purposely don't look at the entries ahead of time because I like to be surprised by them.
It
But
doesn't stay still very long. So. All right. We are going to speak. So, Chris here, Chris Rice, is an aquatic ecologist with expertise studying Missouri's stream ecosystems and their aquatic biota. His work centers on applied research, long-term monitoring, and collaborative conservation efforts across the state. In his role with MDC, Chris leads research and monitoring initiatives that inform the management of streams and their aquatic fauna. As the statewide taxa expert for fishes, he provides guidance on fish species of conservation concern and supports recovery efforts for federally listed species. So he can definitely tell you what you're not allowed to take home.
yeah,
He can also tell you what you can.
That might even be better.
Most of it. Chris's background includes words I cannot pronounce. Eco-hydrology? Eco-hydrology. All right. I didn't want to pronounce it at all. All right. Stream community ecology, I nailed that one, and hydraulic modeling. Along with extensive expertise collecting and analyzing biological, physiochemical, and spatial data. His work spans, oh God, how many big words do you have in here? Bathymetric? Is that like how deep a bath is?
That's like, think of like a topographic map.
Topographical map underwater. And hydraulic assessments, quantitative fish and invertebrate surveys, and data synthesis for guiding conservation management decisions. Work reflects a commitment to practical, science-based conservation, and we're super happy to have you here tonight, so please give Chris a big round of welcome applause. Too much.
oh, that's a good call.
We're missing Megan tonight.
No, we got this.
You got this? You know how to set it up?
Nope.
That's what we want to call it. It's just going to be a little harder to hear on YouTube tonight.
We can maybe figure it out.
All right, you guys try to figure it out, but we're not going to spend a lot of time.
Well, he could do improv jokes for
You could do improv jokes
20
for a
minutes
while.
or so.
Let's.
No? No.
Micah unplugged my carefully set up thing,
Sorry, buddy.
so he did not succeed at
That's what I'm best at.
showing my grumpy fish. Dude, he even left your stuff up? Oh, wait. Best laid plans lay waste to missing men.
It's not the quote.
You can move the camera.
It's important.
Wherever you want.
I'm just waiting for you to move.
Do you know how to do this?
I can plug things in.
In a tone, so it's like a metronome back.
Yeah.
All right,
So yeah.
let's go.
So Steve is an expert at that.
That's Selwyn's responsibility. This is for Chris.
Yeah, I think so.
Is it on? It doesn't look on.
Probably not, but
Maybe press
there's a
on.
cord.
For those that don't know, we normally do have a couple hundred people that watch our talks live on YouTube.
Here, try this one.
Not necessarily live, but a lot of them live, including globally. Put that on somewhere not too close to the other. Not all the possible. It's ready. It's ready to be mic'd up. All right, thank you, Chris. We're excited.
Does that work for you? You got audio?
Sure.
Yeah, it's coming through.
Oh, so you connected to that.
Yes, sir.
Thank you for the introduction. I'm
So
not happy
connect
to
this,
that
something.
bio made me sound. That's my official bio, so maybe I should have.
It made you sound smart. It made me sound dumb. You know?
But I really appreciate MASI's generosity. I really appreciate your donations in the past, I think, year or so, contributing to this research project that we are getting up and running the Department of Conservation. So I think Travis Moore, my colleague, came and spoke to you last year about sturgeon. We're not going to be talking about sturgeon today. We're talking about little fish. Big change of pace. But before I get to that, I'm going to tell you a little bit about who I am and the work that I do at the Department of Conservation here. So like Steve said, my official title is aquatic ecologist. That's my background. I have a background in biological science and stream ecology and that type of thing. However, my role with the Conservation Department is really more of a programmatic lead. So what I do is that I would do a lot actually, but like what's on the slide here is kind of my principal responsibility. So firstly, that's conducting monitoring for our state's federally listed fish species. So that's population monitoring. We want to know through time how their populations and their distributions are doing. So that will eventually inform management of coverage. I also work with colleagues both within the department and within other agencies and universities to formulate research to inform the management of those federal listed species. I oversee some of the species recovery management, and that's kind of what we're going to be talking about later today in this presentation, later tonight. I serve as the state heritage biologist for fish. I won't call myself a theologist because that's those people who actually are, but I am a heritage biologist. So that means I approve all of the records for the fish, whether they're state listed, federal listed, or just species of concern. We track those in our internal database. Send all of those data to NatureServe. And then I also curate our own internal databases too, so we have a pretty good handle on where fish occur within the state of Missouri. And then I also maintain a reference collection, and that's up in Columbia, and basically that goes, that's all of our preserved fish specimens, well not all of them, but many of them, mass on the planet. So studying and managing these species is not only important for the ecosystems that these fish inhabit, but it's important for people that rely on those fish, the people that rely on those ecosystems. So that's why we do it. So, like the previous slide said, there's about 33,000 species of fish worldwide. And of course, new species are added each year as we discover new biodiversity and understudied regions of the world, or cryptic biodiversity is discovered within species that are already described. Most of those fish are marine, about 60%. But 13,000 of those, so about 41%, are freshwater species. So under half of the total global fish species are freshwater. However, like the bottom bullet there says, only about 0.1% of the world's water supply is liquid freshwater. So despite covering less than 1% of the Earth's surface, freshwater ecosystems support a disproportionately large share of global species. Why is that? I mean, that's unreal when I see those numbers when I was coming up in this field. And there's a lot of reasons why, but I think primarily a lot of it has to do with habitat heterogeneity in freshwater systems. Think about any drainage network, any stream, how different they are. The photo on the bottom here is Deer Creek in St. Louis County. Just a couple of miles away from that is the confluence of the Mississippi and Missouri rivers. How drastically different, both physically, chemically.
Mississippi.
Yeah, is that what I said? Missouri, Mississippi. Yeah, they're huge. They're huge rivers, and they're completely different from that small little stream just a few miles away. So there's a lot of different habitats, a lot of different niches for species to evolve and specialize in. And beyond that, streams are inherently fragmented. So I'm showing a map here of our major drainage basins within the state of Missouri, and that little red square is just kind of an example. You can see down there in southwest Missouri, there's two streams that little red square is kind of focused around. One of those is the North Fork of the Spring River. The other one's a creek that I can't remember the name of. But the point is, Euclidean distance, like linear distance, those creeks are only a few miles apart. Those streams might only be 10, 12, 20 miles apart. They're not that far apart. But the river, species would have to go all the way down the Arkansas, the Neosho River and into Arkansas, through the Arkansas River, back up the Mississippi, and all the way up that's thousands of miles. So as you might expect,
species occurring here in the orange, the Neosho River Basin. The assemblage there is quite different than what occurs in the neighboring Missouri River Basin. So, of course, those conditions create evolutionarily isolating environments in which rapid speciation can occur. So that's why we got so many freshwater fish species on the planet. And those lead to some really interesting trends. So what I'm showing you here is a map of freshwater fish species richness around the globe. The red areas indicate areas of higher biodiversity. And you can see, kind of where you'd expect it in the tropical areas. You've got South America, Central Africa, Southeast Asia, but also this is probably the first thing you saw. Got a little bit of red up there in the US too, which is a really neat thing. Got a really biodiverse region. Looking at that a little bit more closely. Again, this is kind of a heat map of fish species richness in the US. And here, you can see Missouri fits in pretty well with some of the Southeast region states and having very, pretty reasonably high fish biodiversity. And in Missouri, we're sitting at about 240 species of fish. Of those 240, 222 are native, 18 are introduced. That number ebbs and flows with the taxonomy. Some of the photos here are just some examples of our native fish. Most of them are darters, a couple are minnows. But we have some really beautiful fish that you can find in this state, not too far from here. And in my opinion, native biodiversity is the foundation of healthy ecosystems and, of course, healthy people. So that's what we do. Now, fish are also an imperiled group of organisms. This is an outdated, this is a pretty old paper that this figure was taken from, but the trends still hold today. Basically showing species imperilment by major taxonomic groups, major faunal groups in North America. And if you can draw a trend from that, you can see the first 5 groups, well, those are all aquatic organisms that live in streams. Yeah, fish aren't the number one. The mollusks and crayfish are, but about 40% of species at the time were imperiled, and that number has only gone up over time.
Stoneflies are having a hard time, too.
Stoneflies. So getting a little bit more into our native or at least our state's fish fauna, like I mentioned, we have 18 currently recognized non-native species. That includes things like your silver bighead carp, common carp, trout, things like that. Those are introduced and non-native species. Of our remaining 222 native species, we have 65 fish species of conservation concern. That's a term that we use internally at the Department of Conservation to basically indicate species that they're in trouble, they're declining. But they don't have any federal or state listing status. These are species that we prioritize for research and monitoring management purposes. Now, of those 65 species, there are 19 fish that are state listed endangered. There are 7 that are federal listed. 3 of those are federal endangered, 4 of them are federal threatened. 1 is extirpated, but actually it's not because we just found it again, so that's pretty cool. Pallid shiner, so this species was drastically declining over the course of the 20th century, and our collectors back in the 60s and 70s documented that this species was pretty much absent from some of its, from its entire historic range in southeast Missouri. And I think it was probably about 6 or 7 years ago, one of our collectors actually found it again. So. And since then, we've implemented several basin-wide inventories, and then we have found more of these pallid shiners down in southeast Missouri. So it's not all doom and gloom. Sometimes fish make comebacks. And among those fish, there's 6 petitioned for federal listing. So I'm going to talk a little bit more about our endangered species here. So we've got federal listed species. These are the 7 that are federal listed species, if anybody wants to know. So for endangered, we have grotto sculpin. That's a stylobitic cave-dwelling species that's found in southeast Missouri. Pallid sturgeon, limited to large rivers. Topeka shiner, that's a little minnow, and that's the one we're going to talk a lot more about today. Threatened species, Neosho madtom, a little catfish. Niangua darter, Ozark cavefish, and shovel-nosed sturgeon. Shovel-nosed sturgeon are listed with a similarity of appearance rule because they are, for many folks, they're indistinguishable from pallid sturgeon, so they are listed where the 2 species co-occur in commercial waters, just to protect it from overharvest. So that brings us to our focal species for the evening. So we're talking about Topeka shiner. This is a minnow, like I said in the last slide. This is a little fish. Basically, adults at their maximum size are getting up to about 2 inches long. So they're little fish. They have a distinctive wedge, kind of chevron shape there on the caudal peduncle at the base of their tail. Some other minnows will have that, but Topeka shiners are one of the few in Missouri that do. These fish primarily inhabit small headwater streams in the prairie region of the state. So think like north of the Missouri River and kind of western Missouri near Kansas City. They spawn on sunfish nests, so that's an interesting symbiosis there. They require basically like orange spotted and green sunfish to kind of procure the substrate like gravel that the fish will use to spawn on. And this fish was listed as federal endangered back in 1998. This is a map highlighting our state's aquatic faunal regions. This was developed by our state ichthyologists many, many years ago, Bill Flieger, basically just showing that we have 4 distinct faunal regions that contain very unique fauna and streams. And today we're going to be talking about those up in this area, this yellow, the prairie faunal region. That's where our Topeka shiners are, or at least they were. So looking at Topeka shiner here, the inset there in the bottom left of the slide, that is the blue outline there is the historic range of Topeka shiner in the upper Midwest. You can see it was found in northern Missouri, through Iowa, into Minnesota and South Dakota, over to Nebraska. The yellow polygons represent the current range, and even these slides are even a few years old, so pretty precipitous decline over the years. And in Missouri specifically, these points represent collection records, with the white being older and the red being newer, so you can kind of see that decline through time. Basically, we're down to 2. We're one in extreme North Missouri and then one kind of in central Missouri. That's where we're at right now. So the species overall has not been doing well, and it needed some kind of urgent management intervention. So in 2010, the Missouri Department of Conservation developed its own internal state plan. I wasn't around for this, but we still use this plan today to kind of guide our management and research on this species. The overall goal was to stabilize and enhance populations in 7 streams, realizing that it is impractical and unrealistic to bring that species back to its former range. We wanted to secure its genetic diversity throughout 7 populations throughout the state within the historic range. To do that, there's 4 key points we needed to focus on: habitat improvement, research, establishing new populations, because you saw in the previous slide there was only 2 left, so we would need 5 more. And then monitoring those populations to make sure the work that we're doing is actually effective. So thinking about the habitat improvement, what does this fish actually need? Well, it's a prairie fish, so really what it needs is kind of like what you see down here on the bottom right. It needs small prairie streams with stable riparian corridors, so they need lots of vegetation on the edge to keep the stream kind of laterally stable. It doesn't want to meander too much or have too much erosion. It needs decent, water quality, an array of natural habitat, so that would be like, different types of substrates. I mentioned needing the gravel substrates to spawn on. A suite of other prairie native fishes. They don't really do well in monoculture, where we find this fish is often, pretty diverse community. There's always many other fish species there. It's never just this one. And ultimately, hopefully we try to encourage, landowners to conduct these type of activities that, hopefully it will make their landscapes more healthy for the long term and more profitable than something that you might see here, which is certainly, that's going to cost resources for a lot of farmers over time. So getting at the reintroduction, that's really the core of this, is introducing new populations. Like I said, the goal in that plan was to get to 7. And each of those 7 needed to have self-sustaining populations within 3 watersheds, having at least 50% of the stream reaches within those watersheds occupied and stable over the monitoring frame. So that brought us to our reintroductions. This was like 2013 through 2015-ish. Basically, what the Department of Conservation did was work with the Fish and Wildlife Service and collaborators to develop non-essential experimental populations, or NEPs. This is under the U.S. Endangered Species Act. Basically, it allows you to establish new populations of a listed species within its former range, but with different criteria. So these are basically non-essential. They're not essential to the species' survival. That doesn't really sound intuitive, but the reason for that is it provides greater regulatory flexibility so that landowners, most of the folks up here are, they're running cattle, they're growing crops, corn, things like that. It's so that these activities won't cause incidental take to the species. So really what it is that it only prohibits activities that are intentionally harmful to the species. So really, the idea is just to kind of balance recovery with, with landowner concerns. So that gets us to the research project that you all graciously funded for over the past year. That's a project that we have going on in North Missouri in collaboration with the University of Missouri-Columbia and the Nature Conservancy as well. It's on some of their property in North Missouri. And basically what this study involves is these beaver dam analogs. And I suspect most people haven't heard of those because I hadn't heard of this either until a couple of years ago. So what it is, what a beaver dam analog, or BDA is an artificial structure shown at right that is supposed to mimic the structure and function of a beaver dam. So that sounds kind of silly, but they do have a purpose. And it is mostly a hydrological purpose shown here. So what we want to do in a lot of these prairie streams, they've been degraded with time. They're really incised. The bed has been down cut. We want to slow water velocity during flood pulses, kind of impound water, encourage sedimentation and bed aggradation to reestablish natural sinuosity of the stream channel. That comes with, that creates habitat complexity. That creates habitat for these fish. A benefit of these structures is that they're pretty dang cheap to put in because it's wood for the most part. We get all the materials locally. The beams, the rods going into the stream bed there are basically cedar. They're cedar that were cut down locally, and everything else used inside the structure is cut locally, except for there's like some coconut fiber that they use as well, and that's brought in. But the point being, they're affordable structures to use. They're often installed in series, so there's usually not just one, because the point is to restore a broad reach of stream, not just one little location. So it's usually think like 3, 4, 5, 6, all say within a mile or so of stream. These work best when they're adopted by beavers because it's wood. It's a very temporary structure. This is not meant to last any more than a couple of years without maintenance. So the idea is that you have a natural beaver population occurring in water bodies nearby. Those beavers come in, they kind of like keep piling on top, especially when there's floods that might come in and damage the beaver dam analog. You want the beavers to come in and take care of that mess for you. That's in an ideal, perfect world. So this is a technique that's been gaining traction in the U.S., especially out west in the western states. For us in Missouri, this is the first time we've ever done this. So this is completely new. This is a pilot project. We have no idea how it's going to work. So we are piloting this in 2 areas in Missouri, one of which we're going to talk about in a little bit more detail now. So we've already talked about this. Why do we install the BDAs? This photo to the right, this really just shows the condition of some of the streams, some of the prairie streams in North Missouri. Look at the channel incision there. I don't know how tall that is, but I'd say it's probably 6 feet, maybe more. The slide says 3 to 10 feet, so it's variable. But basically what has happened over the years is excessive erosion and high velocity runoff from flood events has just downgraded the channel. It's really straight, it's really narrow. There's not a lot of habitat complexity in there for fish and for other organisms to use. And the soil up here as well is pretty easily erodible, being a loam, kind of sandy clay soil. It just kind of sloughs off like that. As soon as the bed starts to go, when the stream bed starts to go, the banks just follow suit not too long after. So what do we want to do with this? This is our chance to take a fairly simple and cheap management tool, put it on the ground, and actually have an impact. That's really what we wanted to do, is have a measurable impact here. With a lot of natural resources, conservation in general is doom and gloom. Things are not so good. Species are declining. Basically, the whole first part of this presentation. That's the point of this project. Let's see what we can do to get this species back up to where it needs to be. So, again, BDAs, this is a very novel technology for us. Most of the work has been out west, and as such, we don't really know how this is going to work. One thing, and the third bullet there is highlighted in yellow because there's no information about how fish can move, at least minnows in Midwestern prairie streams. How can they move between these different structures? And that's important for fish too. They need to be able to move. You're probably well aware of all of the money and time that goes into removing barriers to aquatic organism movement. It's primarily out west, but it's other places too. So it kind of seems silly to be putting in barriers to movement. Well, that's part of this, is to understand whether fish can move through. In theory, these structures are porous. They're made of wood. They're made of basically wood and mulch and other types of debris. So fish should be able to move up and down freely. Water should be permeating through those structures at all times, at least when there's flow. So where are we at here? We're in North Missouri. We're way up near Iowa. This is a Nature Conservancy property. We've got 4 stream reaches of interest right here. And the one we're going to be talking about is West Fork Little Creek. It's circled there on the bottom portion of the screen. So the fish passage component of this project that I'm going to be telling you about is just a small sliver of a much broader project that's really looking at how these BDAs can change the overall morphology of the streams. Like, how do they actually change the channel sinuosity, the velocity, the substrates that are in the stream? That's really what this project is looking at. And it's a 4 to 5 year project, and year 1 was designed to look at the fish movement. So that's really what we're talking about here, is the fish movement. Do fish actually move through these things? So looking a little bit closer at West Fork of Little Creek, this is a map of the study area. Those black triangles there represent the Beaver Dam analogs that were installed in December of 2024. So the money for this project, we just got it in fall of 2024. The field team got right out there and got the Beaver Dam analogs installed in December of 24. And it wasn't until just this past spring of 2025 that we had our first season of data collection. So this is very new for us. So there's 6 Beaver Dam analogs all installed along this treatment reach here. And what we're doing to assess whether fish are moving through these structures is we're actually tagging them with they're called PIT tags, PIT, so passive integrated transponder tags. Basically what these things are like little thumbtack, like tic-tac kind of tags that get inserted into the fish's body. And when they pass through a reader, it reads a code. You can tell where the fish has been and when, basically. It's a pretty neat and simple technology that it's pretty cheap too, so we can buy a bunch of tags and put them in little fish, and hey, it seems to work. So in early 2025, we tagged 211 fish all throughout this reach here. Only 10 of those were Topeka shiners because, again, this is a rare fish. It's not really abundant anywhere. So we tagged fish representing the entire fish community that was present at the site. And here's what that operation looks like. So the top little photo there, that's one of those pit tags I was telling you about, and that's somebody's thumb. So they're really small, at least by our standards, but you can imagine putting that into a fish, it's probably pretty big. The technology here, these are the pit tag, these are like the transponders basically. Like when a fish that has a tag in it swims underneath this, it reads a code out. and we'll know when the fish went through. And then the person in the field kind of records that in the book. The idea is that these big discs span the whole channel, and it actually works for these small prairie systems because they're really little streams. They're like 3 feet wide in most places, so it works there. In a lot of other places, this technology wouldn't work, so we're fortunate in that regard. So this is just a list of fish species we tagged in the first year. This is most of what the fish community would look like in this stream. It's pretty simple, just consisting of looks like 11 species there. Some of the more common species, they're up here. Topeka shiners, you see they tagged 10 of them. So in total, 211 fish tagged. The idea was that hopefully we would see most of those return. So of the 211 tagged, about 46% of those actually went through one of those pit tag readers at one point. So it's really, this graphic is just kind of to get at mortality and whether all of the fish are dying after getting the pit tags inserted or not. So we know that about at least 46% of them didn't die, so that's good. So some general success with this first year of the study. We detected 19% of the fish tagged upstream from those BDAs downstream. So basically what that's saying is 19% of the fish tagged upstream moved downstream. So that's pretty good success, 1 in 5. Of the fish tagged downstream of the pit tag readers, about half of them moved upstream. So that's good too. So what we can take from that, at least as constructed, the beaver dam analogs don't impede fish movement upstream or downstream. So that's a pretty solid takeaway. These are just some graphs kind of showing the past success by the different, there was 3 stations where the loggers, the pit tag readers were installed. Basically the takeaway is that, yeah, fish move upstream and downstream. So I won't spend too much time on those slides. This is a little bit more interesting. This is kind of showing the passage by species. And the numbers at the bottom of the graph there are the total number for each species tagged. So basically, the more of each species you tagged, the more likely you were to see a return on the fish. Actually makes sense. So of all of those species on the previous slide, that was 11 species. There was only 4 species that we documented going both upstream and downstream. And those were some of the more common species. So again, probably a numbers game. And this slide is just illustrating basically how the technology works. This fish down here, it's a green sunfish. This was tagged April 30th, 2025. The way it works is fish goes over the reader there in yellow, the yellow circle is the pit tag reader. 2:46 a.m. on May 3rd is when it crossed that line. So it sent a signal. We know the fish went by there. Okay, fish is moving. The fish is moving upstream. That's actually the structure that it passed through. So green sunfish got through that. Seems successful. This fish kept moving again the same day, May 3rd. I think it was same day. Yep, same day. So a little bit later, it's still on the move. It's moving through the next one. And you can see this one here. This one's had some flow damage, a little bit of a notch taken out, so not too surprising that the fish actually passed through that structure. Oh, and then it was actually, let's see, like a month later at this point, the fish moved again. So it moved through all 6 of the structures, all 3 of the readers over the course of, I don't know, a little over a month. So at least in terms of fish movement, our design seems to be successful. So again, from this 1 year, just 1 year study, we physically confirmed that fish can make it through the beaver dam analogs. However, it wasn't all good because in 2025, the area got a huge rain in May. All of this tagging, most of the research had been done prior to the flood, but the flood in May 2025 actually damaged a lot of the beaver dam analogs. So that's not ideal. So, like I mentioned earlier, the point of these structures was to be able to resist at least a little bit of weathering and then have beavers hopefully come in and maintain them for us so that they're a low cost, low commitment kind of structure. That hasn't been the case so far. That's kind of been the problem, is they're not too resistant to the high flows. And like I mentioned, these streams are only 3 to 5 feet in total wetted width a lot of times, but they do get a lot of water. They get a lot of water in the springtime, surprising amount of water. And what the PhD student out here who's the lead on the research found was he was actually out there at one point monitoring what was going on and during a flood, and he found that the flood pulse, the water that's flowing through there during the flood, basically just picks all this matting up. It just picked it up. So the problem wasn't the hard structures there. It was just like the matting and the reinforcements. It just picked it up. And as soon as that happens, the whole thing falls apart. All the sediment that was supposed to be being held back, this channel sinuosity, that's all gone. It just gets flushed right out. So that's not good, and that's something we'll need to work on. And in fact, he's out there doing that today. So he's up there fighting the good fight, working on rebuilding those. This year he was going to use more cedar posts. Like I said, that probably wasn't the problem, but we're trying to be completely sure that this doesn't happen again. And introducing some new burlap materials to kind of help with some of the sediment aggradation, because that's really what we want. We got to keep the structure in place to accumulate the sediment and kind of introduce that sinuosity to the channel again. So I think that's his, and the PhD student on this is Seth Callahan, so I'll just say Seth from here out. But Seth is up there working on this project right now, and those are from last week, actually, when he was preparing to kind of rebuild some of the structures. You can see there's cedar in there. New for this year, he's got these kind of like coconut fiber. I don't know what they are, but they're made out of coconut fiber, so they're supposed to hold things back a little bit more. We will see how it works, and there's one of his bundles there. So he's just wrapping things really tightly, staking it down as best he can. Just some more photos of the installations. Much more robust this time around. So this will be year number 2. We'll see how it goes. Here's another before and after. This was basically, the left photo was after the first installation in 2024. So we're talking early spring 2025. And the photo on the right is last week, so a little bit more robust. June 25 and February 26, so close enough. So in 2026, what we're going to do is repeat this with our new modified structures, expand to another site, and incorporate another type of tagging technology. Still pit tags, but a different type of reader, one that's capable of expanding across a little bit larger stream. And this just talks a little bit about the new site on the East Fork Big Muddy Creek. That's in the same general area, just a handful of miles away to the northwest. And basically what he's doing here, and this is not the Prairie Stream, this is somewhere in the Ozarks, so not to be misleading. This is the system he's using, though. It's called a Litz cord system. Basically, this thing rolls out like a ladder, like a rope ladder or something across the stream channel, and it performs the same function as the other readers we talked about earlier. The benefit to this particular system is that it's just a wider stream channel. So there's more photos of the installation from last week. There's the study site. And so this year in 2026, those will be the study sites for this fish passage component of the project. So that's ongoing, and like I said, there's probably 3 to 4 more years of this project. Not the fish passage component, but the whole thing. So it will be a much more broad project when it's finished here. So we're just getting started. So what have we learned in 1 year of data? Kind of reiterating some of the things I already said, but multiple fish species can pass through it. That's good. That's really what we wanted to see. We did not want to see putting barriers in the stream and not having fish be able to pass through them. So that's great. That includes the Topeka shiners. Topeka shiners did make it through the structures, so that's great. Documented upstream and downstream passage for multiple fish species. Again, good news. So I didn't talk about this, but the geomorphology component of this project is basically to assess how the stream channel changes through time in response to these structures. We don't really have time for that today, but the news is that basically it's doing what it's supposed to. You're catching the sediment, we're changing the channel, we're developing a new floodplain inside the already incised channel. That's what we want for that habitat heterogeneity. But the bad part was the floods. That's the nature of working in streams. And the reality was the floods kind of kept those structures from working. Like they lifted up the matting, they flushed out all the sediment. So the take-home message is that the structures seem to work, but they're not as durable as they need to be. So we need to go back to the drawing board, and that's what Seth has been out there doing. This week, last week he was installing them, but he's spent several months trying to figure out how to do this better, consulting with people that know more about design than I do. And another problem is that at least in 1 year of study, we didn't see the local beaver population, and there is one. They went out there and found one. They didn't seem to adopt these structures at all. Well, probably because they already had their own dams built.
Can I ask you a question?
Yeah,
about
go ahead.
that?
Yeah,
Okay, so.
I don't know the beaver trends. You asked me that earlier.
Just that when you're looking at those streams, it doesn't seem like you're gonna get beavers setting up a lodge in that water. It's not deep enough for them to,
Yeah, that's part of the problem.
yeah, I mean, so, you know, it might help nearby, but I mean, I can't see if they can't set up a breeding population, then why would they bother to?
Right. The water's too shallow, and that's
Yeah.
just an artifact of the streams and the way they have been degraded over time. Yeah, they're just shallow chutes, and that's not what we want. We want those pools, but it's tough to get it set up. You're
Yeah.
right, and they may not adopt it, but hopefully they will. So I think, to my knowledge, they say there's some on the areas, and there's some beavers on nearby streams of similar size. I don't have numbers for you, but that's just what I hear. But yes, definitely a problem. We got back there? Yes?
Have you considered trying to do reforestation along the shores of these
Yes.
so that you get something for a beaver to eat? And also the trees, if they did eventually grow, would fall across the stream and make their own little dams.
Absolutely. Yeah, so this is a Nature Conservancy property, and it's being restored from what I believe was cattle ranching type pasture land to prairie. And restoring that, or at least rehabilitating the riparian corridor in some way, is exactly what they want. Yep. So it's in progress. It's just not to the point where there's a lot of large timber at this point. And another one over here.
Are you familiar with a dead hedge?
A dead hedge. I'm
Dead
not.
hedge fence?
No. Can you explain that?
So it's similar to your beaver dam design there. You have a row of two sets of stakes, and then in between the stakes you lay prunings and branches, anything that falls from the trees. And people use this to build like fences around their property, but it's also really good for the local ecology, birds, insects, any small critters that might be living.
And
in
that
there.
might work well in the stream
And
channel, you
I
think?
feel like that would
Yeah.
work really well
Well,
with your
Seth.
Yeah.
beaver dam
Yeah.
design.
Yeah, I might have to talk to you about it. Yeah, I mean, that's part of the process here. You know, like I said, we're early on here, and part of this scientific process is learning and hopefully improving upon things by, you know, getting constructive feedback from people like you all. So yeah, if you want to chat about that, I'd love to hear more. And I believe, yeah, that's all I've got. So there's my email address if you ever want to get in touch with me. And you can see I like fish, so there's every fish photograph that I could cram onto the slide. Yeah, another question there.
I got one more.
Yeah, sure.
Actually, it's a suggestion. I would suggest putting something really hard, like a piece of log, a couple feet around,
Mm-hmm.
right across the stream that totally blocks it at the bottom of this thing.
Embedded into the channel or
Yeah, just sitting there.
sitting on top of it?
Upstream from your poles, and then that would eventually, if everything else washes away, that would keep some of the substrate
Oh,
there,
interesting. Like a
even in the
second
top
barrier.
part.
Yeah, it's like a pre-screening.
And probably would be something that they could surmount at low water if it's only a couple of feet high.
Right.
But it would probably be a permanent pond, even if your structure goes away.
That's an
So
interesting
you-
idea.
So you're talking about just taking
Just take
the trunk of a
log,
tree, just
lay it
like,
at your base, and then put your stakes behind
Mhm.
and then build this other stuff up from that.
Okay. So it's laying laterally across the channel. It's
Right
like-
across
yeah,
the
okay, yeah,
Too low to impede fish.
Right.
right.
a couple-
Right, because you
but
want to
edges,
keep it
right?
below the water line
You
at
have to try
base
to
flow.
grab some of that substrate if it washes away.
Channeling in a few places as well.
Yeah, you probably go under it
Yeah.
eventually.
Chris, you got
Well,
one
we
more
could try it.
question?
Yeah, back there.
I mean, I guess just to pitch in, maybe throw some mud on it. I mean, beavers, they lay down in the mud, the clay, and they do layers.
You think that would make it more attractive to a beaver actually coming in and utilizing it?
That in mud, as it cakes, as it becomes thicker, it'll also potentially help with the materials getting released in the flooding water. But was just my pitch in. My actual question is there, a number for the amount of fish released? I think you mentioned the amount of fish tagged, but is there any kind of like idea of how many fish were there at the start compared to that year?
So they tag 211. So the way it works with the tagging is you tag them, you monitor the fish for a few minutes to make sure it's not going to at least die instantly, and then you just kind of turn them loose into the water. So there's no recapture, if that's what you're asking.
She was asking if, was there a reintroduction? Was there?
Of Topeka shiners.
Topeka shiners.
In this water said yes, but that was like 6 or 7 years ago, would have
Do
been
you know
last
how
one.
many were released then?
Yes, we have stocking histories on all of that.
Oh.
Yep. But it hasn't been stocked in that amount of time. The idea is that it's left to be self-sustaining, and these populations in North Missouri, they seem to be self-sustaining and at least stable in the short term.
Awesome.
So that's good news. Yeah. Yes, sir.
Are the maps that were in your slide, are those public information? Can I find those somewhere?
Which ones? They probably are. Like that.
Yeah, some of those maps, and then the map that you had on, it was the time span map that you had with the collection points and all of that. I think it was earlier on in your presentation. And I'm just interested in like those types of maps in general.
Yeah.
Not just
Most of that stuff is available online through the department's website. It's not always going to be points. Sometimes it'll be county scale resolution. For Topeka Shiner in particular, the points aren't publicly available because it's protected under the Endangered Species Act. But you can find county level resolution. Yep. And you can email me if you want to know more. We can talk about it. Well, thank you all for your time. I really appreciate being here.